हेलो माय डियर मैकेनिकल एंड सिविल इंजीनियर्स, व्हाट्सअप, कैसे हैं सब लोग? अपने किमेनाचेन यल्लावनारू, प्लीज गाइस डू जॉइन मी फास्ट. Myself Chandrasekhar, welcoming you all to this beautiful session. The series is 50 mark series. In this series we ensure at least 50 marks in your GATE examination. We are going to cover those topics, those concepts which are frequently repeated in GATE examination, so that at least you will be able to score 50 marks, and then further you can improve your preparation to get better and better marks. All right. So in this session I will be talking about one of the beautiful concept, interesting and basic, incredible concept of fluid mechanics, that is the Bernoulli principle or the Bernoulli equation. One of the important topics for your all the competitive examination, whether it be GATE, IES or any other PSUs. So please do join me fast, and those who are already here, respond me through the comment section if my audio and visual quality are fine. Can you guys hear me? Hi Anubhav, welcome. कैसे हैं आप? How was your day? I hope everyone is safe and sound and doing your preparation with your full dedication, full enthusiasm and full positive mindset. All right. So those who are watching me live, those who are watching me for the very first time, this is my quick introduction. My name is Chandrasekhar. As I have already told you, I am mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination conducted by UPSC, and I have also worked in Steel Authority of India Limited for a couple of years, and from last 10 plus years, yes, you heard it right, from last 10 plus years, I am completely into teaching, guiding the young generation for various competitive examinations, right? And so with my knowledge, experience and my qualification, I will try to make the Bernoulli equation as simple as possible for you to understand. So these are my favorite subjects. And if you have any doubt in any of the subjects, if you want to connect with me, this is my mail ID. You can always write me a mail. This is my official mail ID, and it is always better for you if you join me on the Telegram, which is Mechanical by Chandrasekhar. And the link is also mentioned at the bottom of the screen for joining my Telegram channel. All right. I hope my video is all fine, because I am seeing the buffering sometimes. Is it all fine? So shall we start? Before we start, let me know your understanding about the Bernoulli principle. There is a simple question, yes or no. You are supposed to give me the answer whether your answer is yes or no. Bernoulli equation can be applied between any 2 points on the streamline for the rotational flow field. Can we apply the Bernoulli equation for rotational flow field? That is the question. थोड़ा buffer हो रहा है? All right. Hi Anonymous. What is your answer? True or false? So many students think, let me tell you, so many students think that the answer to this simple question is false, but to your surprise, the answer to this question is definitely yes. The answer to this question is definitely yes. All right. Let us try to understand how. Yes. Shall we start? Please keep your pen, notebook and calculator. So there was the assignment question given in the previous session Did I give this assignment question previously? I don't know whether I had given this question or not. This is your assignment question. The answer to this question is option C. Did I give you this question as an assignment? No, I don't think so, because the question is from the kinematics. It is from the kinematics. So please try to solve this question. This question is from the kinematics. Let us try to understand the Bernoulli principle from the basics. The Bernoulli equation, the journey of Bernoulli equation starts with the Euler equation. Do you know what is Euler equation? It is just the momentum conservation equation. Euler equation is nothing but momentum equation considering the pressure force and gravity force in the fluid flow. When we consider the pressure force and gravity force, the momentum equation obtained, the momentum equation applied to the flowing fluid element using the pressure force and gravity force is nothing but Euler equation. The assumptions we need to take for Euler equation is, one important assumption is the flow must be non-viscous. The flow must be non-viscous, or we can call it as inviscid flow, or we can call it as frictionless flow. What does that mean? What is the meaning of non-viscous flow? The shear stress developed must be zero, or we can say there is no relative motion between the adjacent fluid particles. The another assumption to be taken into consideration is the flow must be steady. It means pressure, density, velocity, fluid behavior does not change with time. Or we can say the local acceleration will be zero. Local acceleration will be zero. Now, if we apply the momentum conservation equation for a small element using the pressure and gravity force, we will obtain this expression dp by rho plus g into dz plus v dv is equal to 0. This is differential form of Euler equation. This is called as differential form of Euler equation. Now, if we integrate this expression, oh, great, turn up, well done, good, congratulations for your new journey. If we integrate this, then what we will get is integration of dp by rho, first term, then g into z, integration of dz will be z, plus integration of v dv is v square by 2 is equal to constant. That is integration form of Euler equation. These two equations are known as Euler equation. Now, if we add one more assumption to it, listen very carefully. If we consider the flow to be non-viscous, if we consider the flow to be steady, and if we add one more assumption to the flow, that is incompressible flow. What is the meaning of incompressible flow? Density neither changes with space nor with time. Density remains constant throughout the flow. Now, if we add the third assumption, then our expression will become rho can be taken outside. Rho can be taken outside. This rho can be taken outside the differentiation. Then we will get p by rho plus gz plus v square by 2 is equal to constant. This expression is nothing but Bernoulli equation. This is called as Bernoulli equation. The first term in this expression, yes, density is constant, and well done. I am giving you a basic idea, then we will talk about the questions, right? So this term, the first term represents the pressure energy of the fluid. The second term represents the potential energy of the fluid, and the third term represents the kinetic energy of the fluid. And if we add these three energy, it is the total hydraulic energy of the fluid. Sum of pressure energy and potential energy and kinetic energy is the total hydraulic energy of the fluid remains constant. So this, the Bernoulli equation, is applied to the ideal flow. Ideal flow is the flow which is non-viscous, steady and incompressible. So for an ideal flow, the total hydraulic or the total mechanical energy of the fluid always remains constant. So the Bernoulli equation is nothing but energy conservation equation for an ideal flow. This equation is called as energy conservation equation. Let me tell you, pressure multiplied by volume is the pressure energy. M into G into Z is the potential energy. Half into M into V square is the kinetic energy. So if you see mgz, m is missing from here, half mv square, m is missing from here, and if you multiply with m by rho is volume, pressure into volume. So this term represents the energy per unit mass. The unit of each and every term is joule per kg, isn't it? It is called as energy per unit mass. And if we multiply with rho, then we will get the expression P plus rho gz plus rho v square by 2 is another constant. That is another form of writing the Bernoulli equation. Now the unit of each and every term is energy per unit volume, or we can call it as Newton per meter square or Pascal. It is in terms of pressure. Energy equation in terms of pressure. First term is the static pressure of the fluid. It can be absolute or it can be gauge. The second term represents the hydrostatic pressure of the fluid. Hydrostatic pressure, which is due to gravity. Hydrostatic pressure is due to gravity. And the third term represents the dynamic pressure of the fluid. The third term represents the dynamic pressure of the fluid, which is due to velocity. The pressure developed due to velocity is dynamic pressure. The pressure developed due to gravity is called as hydrostatic pressure, and the pressure developed due to static pressure or due to static pressure is called as static pressure of the fluid, gauge pressure or absolute pressure. So the sum of P plus rho gz, this is known as piezometric pressure of the fluid. This is called as piezometric pressure. And the sum of pressure plus kinetic energy or dynamic pressure, static pressure plus dynamic pressure is known as, what is this called? This is known as stagnation pressure of the fluid. Sum of static pressure plus dynamic pressure is known as stagnation pressure of the fluid. Yes, Anubhav. Now, if we divide by rho into g, if we divide the whole expression by rho into g, the first term will be P by rho g plus z plus the third term will become v square by 2g. This is another constant, and here the unit of each and every term is energy per unit weight, or we can call it as head. It is the energy conservation equation in terms of head. First term is static pressure head, potential energy head, and kinetic energy head. This is the expression we frequently use in our analysis. So for the Bernoulli equation, the assumptions which we have discussed is, one is the flow must be non-viscous, tau must be 0. The second assumption is flow must be steady. What is the meaning of steady flow? Pressure, density, velocity are independent of time. The third assumption is incompressible flow. Density is neither a function of space nor time, remains constant. The fourth assumption is there should not be any other form of energy transfer. There should not be any other form of energy transfer. No heat and work transfer. And the fifth and the last assumption is the flow or the point must be taken along the streamline. If we are taking the point on the same streamline, then it does not matter whether the flow is rotational or irrotational. Even for the rotational flow field, the point must be taken along the streamline, or the point must be taken on the same streamline, then the Bernoulli equation can be applied. But if the flow is irrotational, then between any 2 points in the flow field, we can apply the Bernoulli equation. That is the difference between rotational and irrotational flow. I hope it is clear. Because there is no energy loss along the streamline. Even for rotational flow field, there is no energy loss along the streamline. The energy loss takes place across the streamline. So there is the first question on your screen. There is a question on your screen. Can you find out the answer to this question? There are two statements. Statement 1 says the integration of differential form of Euler equation of motion yields to Bernoulli equation. Arnab, when for irrotational flow, Bernoulli equation is valid between any 2 points. But if the flow is rotational, then the Bernoulli equation will be applicable between the points which are lying on the same streamline. That is the difference. Getting it? So statement 1, the integration of differential form of Euler equation of motion yields to Bernoulli equation. Is this correct or not? Is the statement correct or not? The statement is true. The second statement says Euler equation is based on the assumption of conservation of mass. What we should have said, it is based on the assumption of conservation of momentum. Euler equation is based on the assumption of conservation of momentum, not mass. So statement 2 is false. Statement 1 is true, 2 is false. Yes, yes, Anubhav, well done, good, 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 anonymous, great. The next question on your screen. The Bernoulli equation is applicable to both steady and unsteady flow, real fluids. The Bernoulli equation is not applicable to unsteady flows. That is the basic assumption for Bernoulli equation, flow must be steady. Is it applicable to real fluids? No, it is only applicable to ideal fluids. All the fluids, again, it is incorrect. Steady flow of ideal fluid along a stream tube. Steady flow of an ideal fluid along the stream tube. That is the correct answer. Option D. Option D will be the correct answer. Now, when the flow is ideal, what is the meaning of ideal flow? Ideal flow implies that there is always there is no energy loss in the flow direction. If the flow is from 1 to 2, then the total hydraulic energy at 1 should be equal to total hydraulic energy at 2. So what are Z1 and Z2? If this is the horizontal line is the reference line, Z1 is the vertical height of point 1 from the reference line. Z2 is the vertical height of point 2 from the reference line. P1 is the static pressure at point 1, V1 is the velocity at point 1, P2 is the static pressure at point 2, V2 is the static V2 is the velocity at point 2. So if we write in terms of head, so how to write in terms of head? We can say P by rho g plus Z plus V square by 2g is equal to constant, or we could have said P1 by rho g static pressure head at 1 plus Z1 plus V1 square by 2g should be equal to P2 by rho g plus Z2 plus V2 square by 2g. Total energy head at 1 must be equal to total energy head at 2 if the flow is ideal, when there is no energy loss to be considered in the flow direction. But if the flow is considered as real flow can either be laminar or turbulent based on the value of Reynolds number. So we can still apply the energy equation, but we do not call it as Bernoulli equation. It is not a Bernoulli equation. Energy equation will be applied, but we do not call it as Bernoulli equation because the energy losses from 1 to 2 need to be taken into consideration if the flow is from 1 to 2. So if the flow is from 1 to 2, total energy at 1 will be greater than total energy at 2. In terms of head, if we write, then P1 by rho g plus Z1 plus V1 square by 2g, that is the total energy head at 1, is equal to P2 by rho g plus Z2 plus V2 square by 2G plus the head loss from 1 to 2 plus the loss of head from 1 to 2. And the loss is due to friction. So HL can also be called as frictional head loss. It can be called as frictional head loss from the point 1 to 2. If the flow would have been from 2 to 1, if the fluid flow would have been from point 2 to 1, then E2 would have been greater than E1. If the flow would have been from 2 to 1, then we would have written E2 is equal to E1 plus HL from 2 to 1. So what is the conclusion here? The conclusion here says the fluid always flow in the direction of decreasing total hydraulic energy of the fluid. The fluid always flow in the direction of decreasing total hydraulic energy of the fluid, or we can say in the flow direction, the total hydraulic energy of the fluid always decreases. In the flow direction, there is always a decrease in total hydraulic energy of the fluid. So if we know the hydraulic energy at point 1 and hydraulic energy at point 2, we can easily find out the direction of the flow. We can easily find out the flow direction by comparing the total energy. So many students have this doubt. The doubt is, so many students think that the flow takes place in the direction of decreasing pressure. That is not correct. It is not the pressure which decides the flow direction. It is the sum of pressure energy, potential energy, as well as kinetic energy. The total hydraulic energy of the fluid decide the direction of the flow. All right. So let us discuss some more questions. But before that, let me tell you one important information, that we have started with the success of previous ISRO series. We have again started, because there is no notification of ISRO examination yet. That is why we have started another series for ISRO 2023 aspirants. That is the crash course. The technical sessions are going to happen on Monday, Wednesday and Friday, and the general aptitude and engineering mathematics are going to happen on the Saturdays, right? So the series has already been started from today. Today Dheeraj sir had already taken a session on strength of materials at 11 a.m. The timing will be 11 every day, and the next session will be on 17th for strength of materials. Then I will take the fluid mechanics sessions. It will be combination of formula revision as well as the numerical practice. For first 15-20 minutes, we will discuss the related formula of the subject, and then for the next 45 minutes, we will discuss the numerical practice. So it will be combination of revision of the formula as well as the practice sessions. So ask your friends. The series is running on YouTube. All right. So ask your friends also to join in large number. Yes, try to solve the next question. Every one of you, please give it a try. Question says, at location 1 of a horizontal pipe, whenever the pipe is horizontal, Z1 is equal to Z2. When the pipe is horizontal, Z1 is equal to Z2. Potential energy at 1 will be equal to potential energy at 2. The fluid pressure head is 32 centimeter. What is the meaning of that? It means P1 by rho G is equal to 32 centimeter. And velocity head, V1 square by 2G is the velocity head, is equal to 4 centimeter. The reduction in area is such that the pressure head drops down to 0. It means P2 by rho G becomes 0. Then the ratio velocities at location 2 to that at location 1 is equal to. What is the answer? Can you guys give it a try? Yes. So if we write the Bernoulli equation, P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g. Z1 is equal to Z2, P2 is 0. What is P1 by rho g? P1 by rho g is 32 centimeter plus this is 4 centimeter is equal to V2 square by 2g. So V2 square by 2g become 36 centimeter. So the question is to find out V2 by V1. So we can say V2 square by 2g upon V1 square by 2g is equal to 36 divided by 4. 9. 2g get cancel out. So V2 by V1 whole square is equal to 9. So V2 by V1 will come out to be 3 will be the correct answer. It is not 9, it will be 3. Option C is the right answer for this one. Clear? Now the next question, again very simple question from the Bernoulli principle. Arnav, why it is 2.7? How you are getting 2.7? It should be exactly 3. A liquid flows downwards through a tapered vertical portion of a pipe. This is, let us say, section 1. This is, let us say, section 2. So the velocity V1 is V. At the entrance and exit of the pipe, the static pressure are equal. What does that mean? P1 is equal to P2. But G and G will get cancelled out now. Even if you take 9.81, then 2G will get cancelled out because it is about the ratio. So V2 is 3 times of V1. So at the entrance and exit of the pipe, the static pressures are equal, P1 and P2. If for a vertical height h, the velocity becomes 4 times. V2 becomes 4 times of V1, that is 4V. Then the ratio of h is the distance to the velocity head at entrance. What do we want? H upon V1 square by 2G is required. Now, if you assume the reference to be the horizontal line passing through point 1, so can we say Z1 is equal to 0 and point 2 is lying below the reference line? Can we say Z2 is equal to minus H? Do you agree? Z2 will be equal to minus H. So if we write the Bernoulli equation, P1 by rho g plus Z1 plus V1 square by 2g will be equal to P2 by rho g plus Z2 plus V2 square by 2g. Now Z1 is equal to 0, P1 is equal to P2, Z2 is minus 1. So we can say V1 is V and V2 is 4V. So can we write, we can say V square by 2G is equal to Z2, that is minus H, plus 1 by 2G V2 square, that is 4V square. So it will be 16V square by 2G. So what we can say, V square by 2G is equal to minus H plus 16V square by 2G. So we can say 15V square by 2G is equal to H, and H upon V square by 2G is nothing but 15 will be the answer. The correct answer will be 15. Option number C. Right? The next question, give it a try. The next question on your screen. There is a smooth pipe of diameter 200 mm, carries water. The fluid is water. The pressure in the pipe at section S1, which is having the elevation from the reference as 10 meter, means Z1, this is Z1, is 50 kilopascal, that is P1. At section 2, elevation is 12 meter, that is Z2. The pressure is 20 kilopascal, that is P2. P1 is 50, P2 is 20, and the velocity is 2 meter per second, that is V2. Which one of the following statements is correct? Can you solve it? This is beautiful question. What we will do is, we will assume the flow direction to be 1 from 1 to 2 or 2 to 1. If I assume flow from 1 to 2, that is my assumption, and accordingly I will write the Bernoulli energy conservation equation using the head loss, because the question is in two parts. One is to find out the direction of the flow, another is to find out the energy head loss, right? Because the pipe is having constant diameter, as the diameter is constant, do you agree velocity V1 is equal to V2 is constant? That is the continuity equation. So if V2 is given as 2 meter per second, so V1 will also be 2 meter per second. So if we assume the flow direction from 1 to 2, can we say E1 will be greater than E2? Or can we write E1 is equal to E2 plus energy loss from 1 to 2? Can we write E1 is equal to E2 plus energy loss from 1 to 2? In terms of head, if we write in terms of head, then our expression is P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g plus HL. Now, if we will get HL, listen very carefully. If we will get HL to be positive, then our direction is correct. If we get the positive value of HL, then the direction will be correct. If we are getting the negative value of HL, then direction will be opposite. Direction will be from 2 to 1. That is from 2 to 1. So find out the value. The magnitude of HL will not change. The magnitude will remain same. It will only be the direction which will be based on the sign of HL. V1 is equal to V2 from the continuity equation. So if we take G as 10, what is P1? Pressure P1 is 50 kilopascal. So it will be 50 upon into 10 to the power 3 upon 10 to the power 3. Let me take G as 10 plus what is elevation? What is the elevation? 10 meter plus 10 is equal to 20 into 10 to the power 3 upon density of water 10 to the power 3 into G plus elevation is 12 plus HL. So if you simplify this, 10 to the power 3 getting cancelled out. So it will be 50 or 10 plus 5. 15 is equal to 2 plus 12 plus HL. So HL will be equal to 14. 15 minus 14, that is 1 meter. Because we are getting positive, so the flow direction will be from 1 to 2. Our assumption is correct. So HL we are getting 1 meter, positive value of volume. So the flow must be from S1 to S2. If we would have got minus 1 meter, then the direction of flow would have been from 2 to 1. But because we are getting the positive value, then the direction will be from 1 to 2 and the loss is around 1.06 meter. Height will not decide, Pawan. Height of the pipe will not decide the velocity. Velocity will be decided by the discharge. We are assuming the flow is steady. For steady flow, we can say discharge will be pi by 4 d1 square into v1, or we can write pi by 4 d2 square into v2 remains constant, right? Or we can say d1 square into v1 is equal to d2 square into v2. So from here we are getting v1 will be equal to v2 as d1 is equal to d2. Diameter remains same. Diameter is 200 mm. Due to Let me tell you, Pawan, due to the change in potential energy, the pressure energy will change. There is a change in the pressure energy. The velocity will only change when the diameter will change. Are you getting it? The velocity of the flow or the kinetic energy can only change when the diameter of the pipe will change. Otherwise, there will not be any change in the velocity of the flow. So, due to change in the potential energy, there will be a change in pressure energy. Right? Got it? Is this clear? So, there is an important announcement again. Again, there will be a national scholarship test for GATE exam conducted by BYJU'S on 16th of July, day after tomorrow. That is on Sunday at 9 a.m. And the scholarship test is important because you will be able to know about your preparation level through this scholarship test. Moreover, based on your performance in the scholarship test, you will be able to avail up to 90% discount in our various courses. So with our guidance through the paid courses and your hard work, this will be the deadly combination to make you successful in your competitive examination. So please do register yourself for this scholarship test. You will be able to get our paid courses with the discounted prices, and the scholarship test is completely free of cost. And on 18th of July at 7:30 p.m. in the evening, there will be a important interactive workshop taken by the Rakesh sir. He is MTech from ISRO Bangalore, All India rank 09, having more than 12 years of experience and also cleared the engineering services examination. So he will be guiding you through the tips and tricks to get 15 out of 15 in aptitude. So many students are very much concerned about their performance or their preparation for aptitude. So all your queries will be addressed in this interactive free workshop. You just have to register yourself and then attend this workshop. I promise you guys that workshop will be very, very beneficial to all the students. All right. Another question on your screen. Yes, this is beautiful. Can you solve this question? The discharge velocity at the exit of the pipe given in the figure is. So we need to take 2 points. What is the answer? Please share your answer. What we need to do is, let me take point 1 at the top of the reservoir. Let me take a point at the top of the reservoir. Pressure is P1, which is 0. Gauge pressure is 0 at the top of the reservoir. Velocity V1 will be 0 at the top of the reservoir. So please guys, do not forget to like and share this session so it reaches to all the students who are preparing for GATE 2023 exam. V1 will be equal to 0 and Z1 will also be equal to 0 if we take this as our reference line, isn't it? So if we take point 2 here, then we can say P2 gauge will also be 0, isn't it? Z2 is equal to minus H and V2 is unknown. So if we apply the Bernoulli equation between 1 and 2, if we write the Bernoulli equation between 1 and 2, can we say P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g. This is 0 gauge pressure, Z1 is 0, V1 is 0 because the point is taken in the reservoir, because area of the reservoir is very large, so velocity will be taken as 0. When the area is taken as very large, velocity will be taken as 0. Is equal to P2 is also 0. Z2 is minus h plus V2 square by 2g. So we will get V2 square by 2g is equal to h, or V2 is simply b under root 2g h. This is the velocity of flow from the Arnab. It is option number C. It is option C. It is not option B. Beautiful question. Is this clear or not? If you have any doubt, you can just let me know. And please do share this session to all your friends. And this is your homework question. Try to solve this question at home and bring me the answer in the next class. Or you can share your answer through my Telegram channel. If you are not part of my Telegram channel yet, please do join me on the Telegram. And at 6 p.m. there is another series, ISRO practice series, which is running on BYJU'S app, free series on app. So do not forget to join me just after the class, that is at 6 p.m. on the BYJU'S app for ISRO practice session for the thermal and heat transfer. All right. So that is all from my side. Important series are running on BYJU'S YouTube channel. One is Sunday Ka Funda. Every Sunday there will be a video uploaded, and every Saturday Knowing the Legends and Raftar series is running. So these series are designed in such a way to make your understanding or make your concept of engineering more interesting and more practical oriented. All right. So do not forget to subscribe our BYJU'S YouTube channel if you have not done it yet. So with this note, let me take your leave for now. See you in the next session. Till then, enjoy, take care, have a good day and a great career ahead. Thank you guys. Thank you very much for joining in, and do like and share this session. Jai Hind.